Welcome to True Projects. In this video, we are going to explain about the project, which is certificate verification and validation using blockchain. Introduction of the project. The project addresses the issue of certificate forgery, which has become a significant concern in the education sector. Many individuals generate fake certificates to enhance their job prospects, undermining the credibility of educational institutions and employers. Traditional methods rely heavily on paper certificates and manual process. These has the drawbacks including the ease of forging paper certificates, the time-consuming nature of manual verification, and the potential for human errors. Existing technologies lack robust mechanisms to prevent certificate fraud, leaving educational institutions and employers vulnerable to counterfeit documents. To overcome these drawbacks, this project introduces a novel solution based on blockchain technology. Blockchain is a distributed data storage technology that creates a decentralized network of nodes. Data is stored in blocks, and each block is associated with a unique hash code. Blockchain's immutability is ensured by verifying the consistency of hash codes across all nodes before accepting new data. Ethereum is utilized for its blockchain capabilities to establish a tamper-proof and transparent certificate verification system. Smart contracts written in Solidity are deployed on the Ethereum network, serving as secure repositories for certificate data. Ethereum's immutability ensures that once certificates are recorded on the blockchain, their authenticity and integrity cannot be compromised, providing a robust solution to combat certificate fraud and forgery. Objective of the project. The main objective of this project is to establish a reliable and effective system for verifying certificates, enhancing security, and combating forgery within the education sector. Blockchain technology is employed in this project to store certificate data securely. Specifically, it is used to create and manage smart contracts in which certificate information, including digital signatures and QR codes, are stored in an immutable and tamper-proof manner. SHA-256, which is a secure hash algorithm of 256-bit, is a cryptographic hash code function that is used in this project to create digital signatures for certificates. These digital signatures serve as a unique identifiers for each certificate, and they are stored on the blockchain. When certificates are verified, the SHA-256 hash values are compared to ensure that the data has not been tampered with, providing a secure method for certificate validation. Requirements for the project are hardware and software. Coming to hardware requirements, processor of i5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. In software requirements, we need Node.js, Python of 3.7.0 version, Visual Studio Community version. To implement this project, we have designed various modules in the methodology. The first module is Education Authority Login. Admin of an education authority will log into the system using username and the password. In this module, we have sub-modules. The first one is Upload Certificates. Educational authorities will upload student details and certificates. View certificate details. Admins can view the details of certificates stored on the blockchain. View company details. Admins can access information about the registered companies involved in certificate verification. Coming to company login, a company user can sign up and log into the system. In this, we have a sub-module, Authenticate Certificate. Here, company can scan and upload certificates for the verification. The system generates digital signature for uploaded certificates and matches them with those stored on the blockchain. If the certificate is genuine, the same signature is generated and authentication is successful. Coming to scanner module, in this we have sub-modules. The first one is QR code scanning. This standalone module is maintained by educational institutions and companies. QR code verification. Users can scan QR codes on certificates using this module, which retrieves details from the blockchain. Certificate validation. If the QR code exists on the blockchain, the module confirms certificate validation. Blockchain integration. Blockchain technology, specifically Ethereum, is used as the underlying platform to securely store certificate data. Each certificate and its associated details are stored as transactions in the Ethereum blockchain, making it tamper-proof and immutable. Solidity smart contracts are developed and deployed on Ethereum blockchain. These smart contracts contain functions and logic for storing and authenticating certificate information. When certificates are issued, their details are recorded on these smart contracts. Blockchain technology, including its use of cryptographic hashing, is employed to generate digital signatures and hash values for each certificate. These digital signature and hash codes are associated with each certificate and they are used to verify their authenticity when they are later accessed or scanned. QR codes are generated based on the hash codes and digital signatures of the certificates stored on the blockchain. These QR codes are affixed to physical certificates. When someone scans a certificate's QR code, the project system checks the associated data on the blockchain to verify the certificate's authenticity. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the static folder. This folder contains files related to CSS, JavaScript and Bootstrap files. These files contribute to the visual and interactive aspects of the application. This is the templates folder. Within this folder, we will find all the HTML pages used throughout the project. It includes pages like index.html, home.html and more, representing various sections of the website. This is the certificate verification solidity file. This file consists of a solidity code. It handles data structures, functions and events with modifiers for validation. This is main.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database and generating dynamic content that to be rendered in the HTML templates. Now we need to open the HelloEth folder. This is the node module folder. This folder contains dependencies or modules needed for our project. Now we have to open it. This is the bin folder. This folder contains executable scripts related to the project dependencies. We have to open it. This is the run blockchain.bat file, which is a Windows batch script to start the blockchain. This script will initiate the local Ethereum blockchain for development purpose. Now we have to double click on it to start the blockchain. Blockchain is hosted on the local address, which is localhost, and the port. This address allows us to interact with the blockchain using various tools and applications. Here we need to execute the command, which is truffle space migrate. And now we need to click on enter. This will compile and deploy smart contract. Truffle is a development framework for Ethereum that simplifies the process of compiling and deploying smart contracts. After running the migration, we will receive a unique Ethereum contract address. This is the contract address. This address represents the location of our deployed smart contract on the blockchain. And here we have gas used. To execute the solidity file and compile smart contracts, this is the amount of gas used. Now we have to minimize it and get back to the main directory. And now we have to run this run.bat file. And this we have created instead of executing the project in command line interface, we have created Windows batch file to execute the project. Now we need to double click on this. Flask framework has started, which is Flask server has started. And the Flask framework has hosted the application at the local default address. And now we need to copy this local link and paste it in any browser. I prefer Google Chrome, so I'll paste it in that. So here we'll paste the link. At the end we'll type index. And we need to click on enter. This is the web page of the project which is displayed in the browser. And this web page is built by using the Flask framework. In the homepage, we can see various links which are educational authority login, company login and new company sign up here. So first we need to click on educational authority login. Admin of the educational institution has to provide his credentials, which are the username and the password. Now we need to click on login. Admin has logged in successfully. And in this page, we can see various links which are upload new certificates, view certificate details and view company details. So first we need to click on upload new certificates to add the certificates. Here we need to add the student details and upload the certificate. So here we will give the student ID, student name, course name, contact number of the student, address, now we need to click on choose file to upload the certificate. So here I am selecting the second image and clicking on open. Now we need to click on Submit. So here we can see certificate details are added with the ID3 and generated digital signature with the hash code. And now we need to click here to download QR code to download the QR code. So in the status bar, we can see that QR code image is downloaded and this image can be saved in his mobile, which is student's mobile. Now we need to click on View Certificate Details to view all certificates stored in the blockchain. Here we can see student ID, student name, course name, contact number, address details, date and time of the uploaded certificate, and digital signature of the certificate and the QR code of the certificate. Now we need to click on View Company Details to see all the registered companies. So here we can see all the registered companies, which is HCL and the password of the company, phone number of the company, email ID and the company address. Now we need to log out and log in as new company sign up. So now we will click on New Company Sign Up here link. Here we will provide all the company details, which are the username, password of the company, contact number, email ID and the company address. Now we need to click on Submit. We can see that company sign up task is completed. Now we will log in as company. For that we need to click on Company Login here link. Here we need to give credentials of the company, which are the username and the password. Here we need to give the password. Now we need to click on Login. So the company has logged in successfully. First we need to click on Authenticate Certificate link to upload certificate copy received from the student and perform verification. For that I am clicking on Authenticate Certificate. Here we need to click on Choose File to upload the certificate. So I am clicking on Choose File and I am uploading the first certificate. Now I will click on Open. Now I need to click on Submit. So here we can view all the details of the uploaded certificate, which are the student ID, student name, course name, contact number, address details, date and time, and the certificate signature, which is digital signature, and the status of the certificate is authentication successful, which means certificate is validated. So now we will upload another certificate and see whether authentication will be successful or not. So for that we will click on Choose File. Now I am selecting the third image, which is third certificate. Now I am clicking on Open. Now I have to click on Submit. So here we can see that uploaded certificate authentication failed, which means certificate is not validated. Now we need to log out. Any company or educational institution can validate certificate by scanning QR code. To do that, we need to open code folder and double click on run webcam.bat file. So I am opening code folder. Now we need to double click on run webcam.bat file. So here we need to click on Start Webcam button to start the camera. Now we need to click on Start Webcam button to start the camera. So I am clicking on Start Webcam. So in the webcam, from the mobile we need to scan the QR code. So now I am scanning the QR code. Once the QR code is scanned, then all the details for that QR code certificate will be retrieved. So here we can see all the QR code details. And now we will scan wrong QR code certificate details. So here I am scanning the other QR code. So here we can see that certificate verification failed, QR code does not exist. In this way, certificate can be validated by using the blockchain. Now we will close this GUI. I'm closing this GUI. Conclusion of the project. Through blockchain technology, the project ensures certificates are secure and resistant to tampering, bolstering confidence in their authenticity. By digitizing and automating the verification process, the project significantly reduces the time and effort required for certificate validation, benefiting educational institutions and employers. The use of blockchain guarantees that once certificates are recorded, they remain tamper-proof and unchargeable, preserving the integrity of educational records over time. The project's user-friendly interface simplifies certificate upload, verification and access, providing an efficient and hassle-free experience for educational authorities and employers.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.